In this video, we're going to continue to look at solving trigonometric equations, and in this video, we're going to focus specifically on equations containing squared trig functions, but also only one type of trig function. So our goal here is still going to be to isolate the trig function, but we're going to look at a peculiarity with the answers that you get when you have a square root involved. So we'd say find all real solutions of these equations. So first things first, we're going to list all infinitely many answers. And then secondly, let's go ahead and consider our first example here. We have 2 sine squared theta plus 1 is equal to 3 halves. The first thing we want to do is basically isolate our trig function. So meaning we need to get other things off of the left side with our sine squared here. We have 2 sine squared of theta would have to equal our 3 halves minus our 1. Or in other words, we'd have to say getting a common denominator there would be 3 halves minus 2 halves that leave behind a half. So now moving forward with division here, we can divide both sides by 2, which is interesting. On the right side, this means that because we are in a trig class, basically you're in a fraction class, but we need to multiply by the reciprocal. Since we're dividing with fractions, we have 1/2 times the reciprocal of 2, that'll be a half times a half. And so what this ends up giving us here then is a squared trig function, sine squared, is equal to a fourth. And so basically, the other step that we're going to add in here that we have not seen in our previous videos is just taking the square root. The interesting fact, though, is that we get a plus or minus, and in this case we get plus or minus a half. So I'm going to put a box around this, and I'm going to say, well, first things first. In previous videos, we've stopped and looked at, what kind of a reference angle would this have to be that I took the sine of to get a half, but then also what quadrants it would have to be in. And because our sine value in this particular case comes out to be either positive or negative, the interesting thing is we're going to get 4 solutions between 0 and 360 just for this equation. So we would say that, what kind of a reference angle would it have to be if we got a sine value of a half? Well, it'd either have to be at a 30 or a 60. So just really quickly want to fill in our values here on the exterior of the unit circle for these basic reference angles that we see all of the time. So we'll remember that they're all being divided by 2. And then down the left side here, we could say 1, root 2, root 3. Up the right side, the same thing, 1, root 2, root 3. Basically, we're trying to assess, where would sine be a half? What kind of a reference angle would you have to have? And because sine value, of course, on our unit circle are y values, we'd say then you'd have to have some sort of a 30-degree reference angle. So what we're going to do is we're going to sketch in all 4 quadrants here, 30-degree reference angles. Excuse me. And because each of these is 30 degrees, what that's going to do is it's going to allow us to find all of these angles in standard position between 0 and 360. So we would have one of our angles here, I'm going to write, is 30 degrees. But our other 3 angles here, because we're going to get 4 in total, looks like we would be 30 degrees shy of 180. So this would be 150 degrees here. We would be 30 degrees beyond 180. So that'd be a 210-degree measurement. And then we would be 30 degrees short of 360. So that would be 330 degrees. Now, because we want to list all infinitely many answers, basically we know that the period of the sine function is 2 pi, or 360 degrees. So that is to say, if we were to add on multiples of 360 degrees to any of these answers, what we know is we would end up with another solution spot with the graph of sine, since it repeats itself. So we would say that these are the 4 solutions here that we've given, and actually I should be clear on this, these are infinitely many solutions, infinitely many solutions here. So we're going to look at another example here, this time with the cotangent squared function, and talk about how we could solve this. So looking at what we have here, first things first, to isolate the cotangent squared, I would get rid of this 2 on the bottom here. So we're going to multiply both sides by 2 to get rid of the 2 on the left. And so we would end up with this. We'd have cotangent square root of x minus 1 is equal to 2 on the right. Now if we were to, say, add 1 to both sides here, then what we end up with instead is that our cotangent square root of x is equal to 3. And so now when doing our squared here, we get a square root. We get cotangent of x is plus or minus the square root of 3. So again, what we're seeing is a situation that when we draw this out, we would say that it would have to exist in all 4 quadrants because tangent is both positive and negative in any of these quadrants. The other thing we're looking for here is what the reference angle would have to be. So knowing your tangent values is a good thing, or knowing that on the unit circle we could take our y value divided by the x value to get our tangent value. But root 2 over 2 divided by root 2 over 2, that would give us a tangent value of 1 if it's a 45-degree reference angle. If it's anything but that, a 30 or a 60, here we get 1/2 divided by root 3 over 2, which is the same as, 1/2 times the reciprocal 2 over root 3. You get 1 over root 3, or as we reduce this or rationalize it, rather, we get root 3 over 3. And up here we get root 3 over 2 divided by 1/2, which gives us just a root 3. So it must have been at some sort of a 60-degree reference angle that we got this equation to be true here. And as a matter of fact, now that I look at it, this is a cotangent function. Ooh, I need to be really careful here. We first of all would need to assess the situation with tangent then. And this would be the reciprocal of our function up here. So we get plus or minus root 3 over 3, which totally changes things. As a matter of fact, looking at this here, we'd say, what would our angle have to be? And this time we'll do it in radians. We say tangent is root 3 over 3 at a 30-degree reference angle. So what we're going to do is we're going to sketch in all pi sixth or 30-degree reference angles here. And then we're going to talk about, well, then what would they have to be in standard position? And so because all of these angles here, reference angles, are congruent, and they're all pi sixth in measurement, then our four angles would have to be pi sixth, okay? We would get another one here that is 30 degrees short of, or pi sixth short of pi. So we would get 5 pi sixth, that'd be a pi sixth short of 6 pi sixth. We would also get 7 pi sixth. 7 pi sixth is a pi sixth past 6 pi sixth. And then a pi sixth short of 12 pi sixth, or 2 pi. This would be 11 pi sixth. And so here's what we need to make sure we do. We need to add on multiples of the period of this function. And because we're talking about a tangent function, then we mean that it only has a period of pi. So we're going to add on multiples of pi to each of these initial answers to get all of the repetitions or repeated angle solutions. Cheers.